All right, so today I'm going to be talking about 7-2 sequence basics. Now, depending on your pre-calc teacher, you either saw these sequences last year, or maybe you saw them in Algebra 2, or maybe you've never seen them before. If you've never seen them before, you should come talk to me. I can help you with it. One lesson might not be enough, but it might also, because sequences aren't that bad, and they won't be a major part of the course. 7-3 is much more important. We'll see whether you've seen that before. Now, factorials. The idea of a factorial, represented by the exclamation mark, is you have a number times one less, times one less, times one less, all the way until you get to 1. So a quick example is something like 4 factorial. 4 times 4 minus 1 times 4 minus 2 times 4 minus 3, which is 1. That should be 24. You probably should have these memorized. It would help. 5 factorial. 5 times 4 times 3 times 2 times 1. 120. I'm going to leave a space for undisclosed reasons. 6 factorial. 6 times 5 times 4 times 3 times 2 times 1. That would be 720. How am I doing this so fast? I multiply that by 5, I multiply that by 6. The key idea here is that you could write 5 factorial as 5 times 4 times 3 times 2 times 1. Well, that would be 4 factorial. You could write 6 factorial as 6 times 5 times 4 times 3 times 2 times 1. That's 5 factorial. You could also write it as 6 times 5 times 4 factorial. Okay, now I'm just really doing these examples to help out with that example, but that's the idea, because after a certain point, it just becomes another factorial. Okay? And so, anytime I see 4 times 2 times 2 times 1, I can get 4 factorial out of that. And these are useful when we're doing canceling stuff. Sorry, this is equal. These are all equal. These are all equal to 720. This is another way of expressing 120. So, how are these all equivalent? Well, here we go. Or how is this helpful, rather? N plus 2 factorial would be n plus 2 times n plus 1 times n minus 1 times n minus 2 times n minus 3 times dot 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 all the way down to 1. Whereas the bottom here would be n times n minus 1 times n minus 2 times n minus 3 dot 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 all the way down to 1. And when you write it in this Christmas color fashion, you would notice that n could cancel with n minus 1 with n minus 1, n minus 2 with n minus 2, n minus 3 with n minus 3, and all the way down to 1 with 1. And that this kind of canceling would leave you with n plus 2 times n plus 1. Now, if your reaction to this whole slide was that, well, this seems like a waste of time, I can't imagine how this would be useful in calculus, you need to get off your high horse and understand of how much of your life in Unit 7 and Unit 8 will be dealing with factorials. Factorials are really important, they grow really quickly, and they will be all over Unit 7 and Unit 8, so you need to understand this. The other way people could have made this connection here was to realize that the top is really n plus 2 times n plus 1 times n, all that stuff, n factorial over n factorial, and that would be another neater way of canceling. Knowing this canceling, I am not even kidding, is going to be a huge part of Unit 7 and 8. Make sure you get on board. A sequence is an ordered list of numbers. 1, 2, 3, 4, 5 is sequence. 5, 4, 3, 2, 1 is a different sequence. The order matters. Write out the first 5 terms of this sequence. So we think about n equals 1. The first term, a sub 1. We plug in 1 everywhere I see n. 1 over 1 plus 1, or 1/2. The second term, n equals 2. Replace 2 everywhere I see an n. 2/3. And you really should be able to see this. A sub 3 would be 3 over 3 plus 1, 4. A sub 4. 4 over 4 plus 1, 5. A sub 5. 5 over 5 plus 1, 6. I don't expect you to write it out like that. I'm just showing that in case it's the first time you've ever heard the word sequence in your life in a math context. What I expect you to be able to do is to just go right down the line. 1 over 2, 2 over 3, 3 over 4, 4 over 5, 5 over 6. And just plug in your head and list them in order. Now, a recursively defined sequence. Recursively means that the next term is equal to 3 times the previous term plus 4. So that's this recursive sequence. Recursive just means they're defined in this way. This guy, these are called an explicit definition. And we'll see if that use of explicit gets me blocked by this force filter. An explicit definition is explicit because if I asked you for the 100th term here, you would just be like, oh, a sub 100, 100 over 101, done. If I asked you for the 100th term here, you'd have to be like, well, let's find the 99th term. Oh, I don't know that, 98th, 97th. And you'd have to count all the way back down to a sub 1, the first term. Now, in practice, it's not like that. In practice, you get your first term down, first 5 terms. Your second term, a sub 2, would be 3 times a sub 1 plus 4. What's a sub 1? 5. 15 plus 4, 19. Your third term. Your third term, a sub 3, would be 3 times a 2 plus 4. 3 times 19, well, that's just 57. 57 plus 4, 61. And you don't show all your work. 61 times 3, 183 plus 4, 187. You just go through it. 187 times 3 is 561 plus 4, 565. Don't worry, you won't have to do that kind of mental gymnastics on the actual test. And even if you did, you just write it out and show that you can still do basic math without the calculator. Write a recursive definition for this sequence. Guess what? Writing a recursive definition is even easier. A sub 1 equals 2. A sub k plus 1. The next term. How do I get to the next term from the previous term? So there's a few standard options. Maybe it's adding. Okay. I added negative 8. Did I add negative 8 this time also? No. So it's not adding. Maybe it's multiplying. And maybe it's something else, so you have to be a lot more clever. 2 times something makes negative 3. 2 times... Oh, sorry, makes negative 6. Gave it away. 2 times negative 3 makes negative 6. Negative 6 times negative 3 makes positive 18. So I would say you take the negative 3 and you multiply it with the term that came before. So that's a nice recursive definition for that sequence. But let's say you wanted an explicit expression. So that if a man on the street asked you, hey, do you know what the 100th term is? You could answer them like that. Okay. Explicit. So, I would look at the first term. This is 2. 2 times negative 3. 2 times negative 3 times negative 3. 2 times negative 3 times negative 3 times negative 3. So the nth term is equal to 2 times negative 3 to the n minus 1. So here, the first term, 2 times negative 3 to the 1 minus 1, negative 3 to the 0, negative 3 to the 0 is 1. So the first term is 2. The second term, 2 times negative 3 to the 1, negative 6. The third term, the fourth term, so on and so forth. Okay? Does that make sense? This is an important type. These both are called geometric. Oh no. Geometric. A geometric series or sequence is multiplied by some number r again and again. They look like exponential. Explosive. Exponential. Wow, I can't spell today. Exponential. Right? It should look like exponential. We're thinking it looks like exponential. Okay? See? Not so bad. We say a sequence converges or diverges. Let's go over convergence. If we have a sequence, and that sequence has a limit, then L is the limit of the sequence. Duh. And that sequence converges. We're saying the sequence converges if it has a limit. The sequence converges just if it has a nice limit. So find the limit of this sequence. Well, I would look at limit as n goes to infinity, 1 minus 2n. Now, if you're getting good with L'Hopital's, you might say, oh, it's L'Hopital's, negative infinity over negative infinity. But that's silly. You shouldn't be using L'Hopital's here. What's the highest degree on the top? 1. What's the highest power on the bottom? 1. So it's the ratio of the coefficients, 1 over negative 2. So it converges, we say the sequence converges to negative 1/2. Okay? Make sense? That's it. Divergence. If the limit does not exist, then the sequence does not have a limit, or more particularly, we say it diverges. So let's try that limit trick again. Depending on where you are with your limit skills, you might be able to make sense of this, you might not. So as n gets bigger and bigger and bigger, what's going on? And you might not be able to answer that, but you know what you can answer? Let's look at the first few terms. This sequence is with 1 in for n, 3 plus negative 1 to the 1, 3 minus 1, 2. With n equals 2, 3 plus negative 1 squared, 3 plus 1, 4. N equals 3. 3 plus negative 1 cubed, negative 1 cubed is negative 1, 2. Oh, I'm sorry. And it's just going to keep alternating back and forth through its whole life. And we ask ourselves, does this approach some number as n gets larger and larger and larger? And you would all say, no, no limit. The limit, the any. But your actual answer would be diverges. The sequence diverges. Over here, let's try writing out the terms. When n equals 1, 0 over 1. The natural log of 1 is 0. You all need to know that. When n equals 2, natural log of 4 over 2. When n equals 3, natural log of 9 over 3. When n equals 4, natural log of 16 over 4. I'll take this time to say, on the AP test, a lot of the time, they will say, write the first 4 terms and the general term. Now, they won't do that so much here for sequences, but you got to get used to that, hearing that for series over and over and over again. Sorry if you could hear that pop. So that's not helpful. So that's not helpful. Let's try the actual limit. Unless you're a calculator. And you may or may not have your calculator for questions like this, so be careful. As always, with your over-reliance on the calculator. I say in class all the time, most of the questions on the test are non-calculator questions. That's even truer on the BC test. Now, how can you do this? Some of you might be thinking L'Hopital's. That's a nice idea, but we should try to simplify before we do L'Hopital's. How can I simplify this? Well, natural logs allow us to take powers outside. The powers become coefficients. And now it's pretty easy to see. Now we have a log over a polynomial. And if you look at the end of lesson 6-6, I talk about how you need to memorize that polynomials always beat log. So converges, and you would say maybe 2-0. They were asking where it converges. It converges to 0, but they're asking, does the sequencer converge or diverge? It converges. Okay? That's it. 2 more definitions. We call a sequence monotonic if it is non-increasing or non-decreasing. So non-increasing. Now I messed this up a minute ago. Non-increasing would mean the next term and the previous term have what relationship? I'm going to take my time with this and think about it out loud. It would mean if you're not increasing, well, my next term should always be less than or equal to the previous term. That would be non-increasing. The next term was less than or equal to. It wasn't getting bigger, ever. Non-decreasing would be the opposite way around. My next term would be greater than or equal to the previous term. Now, I think some BC kids had a hard time with this. They said, I don't understand, doesn't that cover everything? No, your sequence is either this or this. It's either always getting smaller and smaller and smaller, or at least never bigger, or your sequence is always getting bigger and bigger and bigger, or at least never smaller. It's always going in one way, up, 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 or the other way. So here's what non-increasing would look like this. Non-increasing. Here's my first term. My second term is lower. My third term is the same. My fourth term is the same. It's lower, same, lower, right? That's a non-increasing sequence. A non-decreasing sequence would be that situation reverse. I can say the same, same, or I can go up, up, same, up, same, up. Okay, that's what monotonic means. This guy would stop being monotonic if all of a sudden it went down. Non-decreasing means it can't decrease. This guy would stop being non-increasing if it went up. Non-increasing means it can't increase. I hope those two little dots make it clear. Bounded. A sequence is bounded if every term is greater than or equal to some number n, and also if every term is less than or equal to some number m. So, a bounded sequence would look like this. It would have some upper bound. Oh, sorry. Dots are bad. Dots are bad now. It would have some upper bound, and it would have some lower bound. So that's some number m, and that's some number n, the lower bound, the upper bound. And my sequence could bop around in here, decreasing or increasing, or some random pattern. But the point is it never can go past those bounds. If it went out, it would no longer be bounded by the upper bound. If it had no upper bound, that would mean the series went up, 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 up. If it had no lower bound, that would mean the series could go down, 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 down. Okay? Now, these two together are important because together they can show you that a series converges or not without checking anything, without actually being able to do the limit. Meaning if a sequence is monotonic and bounded, it converges. It's a very famous theorem. You are not responsible for learning it for the test, but we're going to do some examples. So determine whether these sequences are monotonic and bounded. So this should look familiar to you. In case you forgot, this was this guy. 2, 4, 2, 4, 2. So, is this monotonic? Well, it increases, so it's non-decreasing. Oh, but then it decreases. Increases, decreases, increase. Okay, definitely not monotonic. Monotonic for one tone, okay? Not one tone. It goes both ways, up and down, up and down, up and down. But it is bounded. Yes, bounded. Okay. How's it bounded? Well, it's always below 4 or equal, and it's always above or equal to. Okay? B. As always with these questions, it helps to just write out some terms. With n equal 1, we would get 2 over 2, or 1. With n equals 2, we would get 4 over 3. With n equals 4, we would get 8 over 5. With n equals 5, we would get 10 over 6, which does simplify to 5 thirds. Okay, dot, dot, dot. So I'm going to erase the ones that are equivalent just to make it cleaner. So you would think, are the terms always going one way? Bigger, 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 bigger. Yes. The top is always getting bigger than the bottom. It's always going up. This guy is monotonic. Is it bounded? Is it bounded? Yes. So if you're increasing, you always will be monotonic. You always will be bounded below. So all the terms are always bigger than or equal to 1. What are they always less than or equal to? Well, they're always less than or equal to 2. And the reason I know that is because I know the limit of the sequence is 2. Okay? You could also say the upper bound is 100. These terms are not ever going to get bigger than 100. But I know the limit. I can do the limit in my head. Many of you should be able to do the limit in your head also. Highest power on the top, highest power on the bottom. I mean, the highest powers are equal, so it's the ratio of the coefficients, so it's 2. Okay, let's start the terms. This is a very, very famous sequence. I will not shut up about this over the next couple of units. Dot, dot, dot. It goes on and on and on and on. The terms are always decreasing. Each term is bigger than the next term. So it is monotonic. Is it bounded? Yes. Everything's less than or equal to 1. And guess what? Everything's always going to be positive. Everything's going to be greater than or equal to 0. So it's bounded below. This guy's converging. Its limit is 0. Okay, number 12. The fun one. Okay. For 1, it'd be 1/2. For 2, it'd be 4/3. For 3, it'd be 9/4. If you're having trouble keeping up, just pause the video, try to write it out. 16/5, and so on and so forth. Is it monotonic? Yes. These things are always increasing. Always increasing. Is it bounded? No. In fact, we would call this guy unbounded. How can you assess that quickly? The top has a higher degree than the bottom, so the limit is going toward infinity. Okay, it is bounded below by 0. It is bounded below by 0. It will never be less than 0. But it's not bounded on top, so we call it unbounded. That's all I have in lesson 7-2. Again, make sure you do the homework. Make sure you do the homework. It's incredibly important that you stay on top of the homework and you don't let it beat you. Otherwise, make sure you come in to ask questions. You guys have a great day. Have a great night. And I'll talk to you soon. Thank you for your hard work. Goodbye.